My name again is Ryan Marrinan. A little bit of background on me. I was a collision repair technician here in Minnesota for 20 years. During that time period, I was certified with several OEMs, ICAR certified, ASE certified, and had a great opportunity a couple years ago to come work for 3M and be a part of an amazing team and be a part of the training team as well here at 3M, and which has led me to be in front of you guys here today. So before we get started, just a couple of housekeeping things that I do want to get kind of out of the way. There are some things that we will not be discussing. So if the questions do come up today, some things that I will not answer directly. We won't be talking about hiring practices, setting repair times, labor rates, material costs, and that kind of thing. If any of these types of topics do come up, we will just kind of transition away from those. With how many people are on the line from across the country and possibly world, it's important to understand that each region is going to be a little bit different. We can't speak specifically to any one of those things. As always, wearing your proper PPE and your safety gear while performing these operations that we're talking about here today are extremely important, and we want to make sure that we're always following, the best safety practices that are out there, and that the information contained in this 3M Collision Repair Academy course is intended for the occupational use by the persons with the knowledge and technical skills to use such information. It is for training purposes only and not intended to replace or serve as a substitute for the information found in the relevant vehicle, part, and/or OEM repair procedures, industry recommended practices, or 3M directions for use. So now that that's out of the way, let's get into today's topic, and we are talking about corrosion protection in the era of post-reinspection. This is a very passionate topic of mine as a technician. This was an area that I found to be extremely important because we want to make sure that we're making repairs that are definitely following the OEM best practices and recommendations, but more importantly, some undetectable repairs. And this is becoming more important as third-party reinspection companies are on the rise. Insurance companies are hiring, staff internally to do these post-repair inspections in these areas, and customers, they're finding out about these opportunities. And with some recent litigations, much like Johnny Eagle and many more since then, the customers are becoming more informed about this, and they're concerned for their safety and the well-being of their vehicles, because let's be honest, they're spending a lot of money on them, and they're going to start driving them longer as we can get them to last longer on the road. So with that, we're going to dive into some, first, what is corrosion protection and how are the OEMs applying it from a factory standpoint? And really, to break it down as simply as possible, this diagram here, these three legs are the critical elements of proper corrosion protection. And in any repair, if you were to take away any one of these three things, your repairs are going to be susceptible to corrosion. And it's important that we understand that as we kind of go through that today, and how they're doing this from the factory right from the very beginning is they're going through a series of these baths. And it's important to understand that when these vehicles are assembled, all the bare steel and aluminum components are welded, bolted, and fixed, to the structure, and the entire structure with all those components on it goes through these baths. They don't do the parts individually. And throughout these baths, when they get to the end here, it's a zinc phosphate, bath, and it's the vehicles are being fully submerged. And in part of that submersion, it's getting the electrode deposition coating, or the E-coat. That's where that terminology comes from when we refer to E-coating. The baths are positively charged and the vehicles are negatively charged. And so that's where that electrode deposition process comes in. But being that they're fully submerged, they're getting all that material wicked into these cavities, right, and around all these weld areas and locations that they don't have adhesives on from it being built. And after that process is when they're going to go into areas like seam sealer, and then onto the paint process and application. So what the OEMs want us to know, and what we need to understand, is that because we can't duplicate exactly what the factory did, it's important to understand that we should leave as many of the original coatings intact as possible. We can replicate with very close performance capabilities what they did from the factory using some products that we have available to us in the automotive aftermarket. And it's important to point out that we always do want to follow the product maker's recommendations. So whether it's a 3M product or a paint company's product, we really want to make sure that we're following all of their best practices, because especially in the case of 3M, we build our products to align, with the OEMs and what they're saying, as we're going to find out here today as we dig in a little bit deeper. But also, importantly too, is if we do remove any of these OEM coatings, again, following the right procedures to restore the vehicle to its original crash worthiness in regards to corrosion protection, and that's going to be extremely important. So one of the things that typically comes up quite often, and I'm just going to get right into this right away, is direct to metal, and in particular, we're talking about direct to metal seam sealers. There's a lot of questions regarding direct to metal seam sealers, and a little bit of misinformation that's out there that we're going to discuss as we get into this first. But what I want to touch on is really what is a direct to metal seam sealer, what makes it direct to metal, and it's an epoxy or a urethane based product typically that has a corrosion inhibitor in it. If we're using products that don't have the appropriate corrosion inhibitors in them on direct to metal, some of them may promote corrosion because of the process in which these chemicals are made and put together. But more importantly, why do we have bare metal seam sealers, right? And it's driven by the industry. It's driven by cycle times. The insurance companies, pushing on us to make sure that we're getting our cars, they want them done faster. The customers want them back sooner. We've become a very, I need it and I need it now type of society. And this has driven us into an area now that the OEMs are taking a step back and looking at this and saying, hey, wait a minute. Some of these products we don't necessarily approve being used on the vehicles. In fact, we're now giving information out there saying we don't want you to use these products. This is our best practice and recommendation. And so it's important to point that out, that a lot of direct to metal products were driven by the industry and not by the OEMs. But what we see in some of the concerning factors with direct to metal products is situations like this image here, where we'll use bare metal products and then we'll paint the vehicle, and if we don't use them properly, we're going to get situations like this. And this was actually a vehicle that we were called back out on. They were involved in an accident, and 6 months later they were involved in another accident, and they really liked the work that the shop did. So they brought the vehicle back to that shop, they pulled the rear bumper off, and immediately called the 3M rep and said, hey, your product failed the last time we did this repair. I'm going to send you some pictures. We need to replace these panels now because we have corrosion on the inside of the vehicle, and the panels are damaged. So we went out and took a look at this, and as you can see by this image here, water is able to get in along the edge of that seam sealer, right? And so if we're using bare metal seam sealers, we got to be concerned with what top coat material are we putting on? Are we getting enough mill build on all the remaining bare metal to protect it, to prevent corrosion? Because rust can start outside of panel bonds, structural adhesives, and seam sealers, and work their way along the metal underneath of them, causing further damage to our repairs and to the vehicle. And that's where we get into, when we use bare metal seam sealers. And I first want to say, as part of this whole process, is that what I'm not saying is bare metal seam sealers or anything that's a direct to metal product is a bad product. What I do want to point out is here, as we're going through this, is some misuses that lead to problems that we need to be concerned with. Like, I just mentioned top coatings, right? And a bare metal seam sealer is only as effective as the top coated material being put over it, right? So we're coming back in here. Are we using the right, sealers? Are we using the right base coats and clear coat processes? And are we following the paint company's recommendations, or are we just dusting on enough to cover up the bare metal so you can't see bare metal through it, and assuming that we have enough protection on there? And what we commonly find is that conversations need to be had between the body side and the paint side more often, because in some of these areas, it might be that they can't get a paint gun in there. It might be in a really tight area on a door shell, or in a wheel well, or along a rocker panel. And if a bodyman has bare metal exposed in and around a repair, it's important that they point that out to either the prepper or the painter and say, hey, just so you know, I've got some bare metal in this area that can't really, it's kind of a difficult situation to see. We just need to make sure we get it covered. And sometimes it might be the painter that has to point out to a body man as they're doing the repair, like, we're going to have to put down a primer here because I can't get my paint gun in there to make sure that we can get enough coverage if you're going to use a bare metal product. And where that comes into play is tight areas. We call what we call the, like, a shadow edge, right? Or the, like, more of the critical edge, where we might not have coverage all the way around on both sides of that seam sealer. And we see this a lot in wheel wells, areas that are very vulnerable to corrosion. And door hem flanges, rocker panels, as I mentioned before. But these are the areas that we really have to be concerned with, and understand that we need to be, double checking that we have coverage before we're sending the vehicle out the door, because these are the type of situations where corrosion is going to start, and especially if it's in a difficult area to see. The customer's not going to find it typically until it's become so large of a problem that it's going to lead to other issues. And what started out as a 2-hour dent might lead to a $6,000 repair that's now going to be done on the shop's dime at no charge, because of some simple steps that may have been missed along the way. So as we kind of talk about these, and when we have technicians in at St. Paul through our training program, more often than not, we hear guys saying, like, we hear you, we understand, we're using primers, but we're not putting anything to bare metal. And then when we ask, what are we using? We like to use the aerosols, the 1Ks, because they're fast, they're easy. They tell us that they're corrosion resistance and can be put on bare metal. And I put those down first. And then I always kind of lead into my next question of, okay, I want you guys to envision, a repair. Say it's a quarter panel replacement. Maybe you're replacing a rear door, a taillight pocket, replacing a trunk lid, and maybe a little bit of repair on a rear body panel. You're talking about possibly a $10,000 repair. If you send it off to the paint shop and the painter said, hey, great job, you spent 4 days putting this together, I'll have it back to you in 35 minutes so that we can get this car out the door, and this is how I'm going to paint it. You might have some concerns, right? And my question here would be, is this an acceptable method for them to refinish the vehicle that you just spent 4 days on, and that's got a $12,000 bill out the door? And realistically, it's not. The performance of these products doesn't match or come close to, like a 2K, product line, say like Axalta or PPG or Spies Hecker. And more often than not, the technicians will kind of, there'll be jokes and there'll be some laughs about it. But then my next question is, okay, if these aren't an appropriate method for refinishing a vehicle that we've just got done, investing 4 days of work into it, how are these any different if we're using them underneath a seam sealer, right? And especially on the exterior, areas of the car, if we're using these types of products on these areas, is it really any different? From the ground up, the factories are concerned about corrosion, and that's why the first step of the process after the car's been assembled, before anything else gets done to it, it goes through that E-coat bath, right? And it's a heat-activated catalyzed zinc phosphate material that's electrodeposition, coated onto the panels. You can't remove that with lacquer thinner and a rag. You could remove any of these two products here or other one-component products at any given point with lacquer thinner and a rag, because there's no catalytic properties in there. There's no binders and cross-linking that takes place with the metal surface itself. And how we highlight this is when we have technicians come in, we have them build panels, and we give them a steel panel such as this, and they prep it. We coat one half of it with a 2K epoxy primer, and then we let them choose which 1K primer to be putting on the other side. And we give them a variety. We've got about 15 different brands and colors that we lay out on the bench, and we say, you guys pick, you guys apply it the way you feel that's, the proper procedure, and then we put it through our salt tanks. And in order for any product to be corrosion resistant, truly corrosion resistant, and follow an ISO or a ASTM certified test, you have to pass in a tank for 500 hours with no corrosion, meaning it goes in and it comes out and it looks like that bottom half of this coupon. And it's important to point out that when we do these coupons, we do only put one coat of epoxy on here, not saying we want to skip a step. In fact, we've had several paint companies, say, hey, we're concerned when you tell technicians that you're only using one coat of epoxy. We always recommend two, and they have to follow our directions for use. And we say, we know and we understand that, we point that out. but we do it this way because we want to show the strength of a 2K epoxy primer versus 3 or 4 coats of a 1K primer on that bare metal surface. And these are some of the concerning factors that we see when we're using these types of primers, because now if you take this and then double it with the fact that you might have a shadow edge where moisture can get in and start doing some damage along that surface, even though you've maybe sealed, based, and cleared over the top of that one component primer, if you have any areas that don't get the adequate mill build of paint and material on there, this is what could start. And once it starts, it'll work its way under paint, it'll work its way under seam sealers, and cause some problems for our repairs. And especially if they don't get out to do a reinspection for, say, 3 to 6 months sometimes because they're overloaded, corrosion may start in these areas and we don't see it, the customer doesn't see it, but all it takes is somebody that knows what they're looking for to crawl under a vehicle with a flashlight and say, hey, it looks like it's already rusting, we've got some problems. So kind of moving from there into, what are the OEMs saying when it comes to seam sealers and cavity wax type applications, and how we're going to prevent corrosion. And I want to highlight, I'm going to bring up a bulletin here in a second. And this was actually a shop that called us and said, we want you to replace this hood. We need you to blend the front bumpers, the fenders. It's a Chrysler Town & Country van. It's a silver metallic. They wanted to blend the windshield post, which meant we had to go up over the top and down the quarters. We had to blend the front doors and the front door mirrors as well, because that, if you're familiar with those vehicles that flop, or that the way the hood rolls over there, there's a very tight transition between multiple panels. The original repair was for 2 hours on the front edge of a hood. That was the original estimate. And the technician, got a hold of our sales rep, and then they called me, and I happened to be available that afternoon and answered the phone and got to talk to the technician. And he explained to me that he used the product that they recommend in here 4 times, and it failed all 4 times. And so they called the distributor, and they found the 3M equivalent brand, and I'm going to come back to that term equivalency. They found the 3M equivalent brand, and they used that 3 more times, and it failed again. And now it's 3M's responsibility to replace all these panels and these parts. And so here's the bulletin, and I'm going to dive into a little bit about what they were saying. So going over here to step 9. So we've gone through the repair process and the body filler process, and now we're getting to the part where we're going to have to do some primers and some seam sealer work. And step 9 says apply PPG, DPLF primer, epoxy primer, or equivalent to bare aluminum only. Now here's that equivalent terminology again, where they're saying, okay, if anybody's familiar with PPG paint lines, you know that there's newer and better performing primers out there than this. And it's PPG who determines, do they have a new product out there, right? To do an equivalency test on any product, it typically takes about 96 pages of a size font 8 test, a list of tests that the product needs to go through. And after 96 pages of documentation and tests, then you really truly know the performance of the product. And unless you're an engineer that knows how to read and understand those documents, are you truly making a decision on equivalency if you pick up another brand? Say you pick up a Sherwin-Williams primer and you say, well, it's the same thing as that, right? Or if you pick up an Axalta primer, it's the same thing as that. It's what I have on my mixing bank. That's what I'm going to use. We need to be concerned with who's determining what is equivalent when the OEMs are telling us what to use, okay? So anyway, step 9, they're telling us the only thing they want on bare aluminum is going to be epoxy primer. Step 10, again, this is an older primer and there's a newer one since this, but they're saying apply PPG K36 primer surfacer or equivalent to the repair area only, right? So now the 2-hour dent that was originally in the top, that's what they're going to put on here. Step number 11, when the primer surfacer has cured, block sand the surface with 500 grit sandpaper or finer to repair or prepare the repair area for primer sealer application. Now, most technicians kind of chuckle at this and say, I'm not going to block sand, primer, 3 coats of primer with 500 grit sandpaper. It's not going to do me any good. 3M's SOP is you're going to guide coat at 240, it guide coat at 320, it guide coat it, and then you're going to do your finishing grit per the paint manufacturer's recommendations, or in this case, the OEM. They're saying a 500 grit or finer. And this is so that we don't have a metallic flopping into a deeper sand scratch than what they've determined to be an appropriate grit to refinish it in. And then moving on to step 12, if the backside of the panel requires repair and seam sealer removal was necessary, it must be restored. Apply SEM 39477 seam sealer or equivalent. And so this is where the shop had said, yeah, use that product. It told me that, you know, it's direct to metal right on there. It's paintable immediately. I followed all the right procedures. And so this is where I asked technicians, I said, okay, what was the problem here? Okay, you walked over the cabinet, you grabbed that SEM product, you're walking back to your vehicle or back to your stall, and the next step of the process is going to be what? And more often than not, technicians are like, I'm going to flip the hood over, I'm going to seam seal it, and I'm going to ship it up to paint, and then it's their problem. And it's usually when I ask around the room and I say, okay, is everybody in agreement? Does everybody agree? And they say, yeah, it's, you know, sounds right to me. And then I say, but what happened to step number 9? Where they said the only thing they want on bare aluminum is epoxy primer, right? So even though that product is telling us that it's approved for bare metal, the OEM is saying we only want epoxy primer on bare aluminum because we know the performance of epoxy primer on bare aluminum, and that other products will perform properly also on top of that epoxy primer if used properly. And it's important to point these types of things out because it's also important to understand that the OEMs are the experts on how the vehicle was constructed and should be reconstructed in the event of an accident, right? And the products in which you're using, so as 3M, we're the experts on how our products should be used and applied to the vehicle. And we develop and work with the OEMs so that we're in alignment with what they're saying in position statements such as this. And same with the paint companies. They're the experts on their products as well. The OEMs are always going to supersede what any product maker or products you're using are going to tell you. And that's, you know, the importance of going beyond, you know, when we start talking about, you know, following OEM repair procedures, becoming a big topic. A lot of people stop reading after the panel's been fixed to the vehicle, right? You've done all your welding, you've determined you've used the right adhesive, you've got the right types and number of welds. We've got our welds all ground down, and you know what? I don't need to keep reading because I've got, you know, 30 years of experience. I know how to mix mud and I know how to apply seam sealer. Nothing's changed. I'm just going to hustle through the next part of this process. But what we're seeing are that the more and more OEMs are stepping up to the plate and saying, wait a minute, you need to keep reading even further. And in this case here, it was actually the technician that pointed this bulletin out to me and said, I not only pulled the procedure, I have this bulletin, and the products still were failing. And we came to find out that he never put epoxy primer on that bare aluminum, which allowed corrosion to start on that panel and work its way underneath the seam sealer. Toyota Crib 186. This was a very valuable crib bulletin to me. I actually worked, I came out of the industry working for a Lexus certified repair facility, and we used this bulletin like crazy. And this actually, the bulletin was published in 2013, and I actually just had a conversation on the phone with Toyota last week to verify that this is still the most up-to-date bulletin. And they said, absolutely, this is the most up-to-date bulletin. We have not changed our stance on this whatsoever. So Crib 186, like I said, I used to keep these in my toolbox. I would staple them to almost every one of my repair orders when I did my supplements, or we were writing the estimate, because this is what I used as leverage with the OEMs, because it had some great information like this. When E-coat is damaged or removed, it should be replicated with a direct to metal or epoxy primer. An etch primer cannot exhibit the corrosion prevention characteristics of a direct to metal or epoxy primer and E-coat over the long term. Therefore, it is not recommended as a substitute for E-coat or direct to metal or epoxy primer. So my question to Toyota was, what is your terminology here for direct to metal primers? And they said, when at the time of this, we knew of 2 paint companies that were working on a hybrid urethane primer that could be used direct to metal. Now, most all paint manufacturers require the use of a wash primer or a 2K acid etch primer to be used in order to get their urethane primers to be properly applied to bare metal. Toyota is here saying that they, per their testing, they have determined that an etch primer cannot exhibit the corrosion prevention characteristics that meet their standards. So they've identified as epoxy primer is the only primer that they want to be using in that on those applications. And they go on further to say stuff like, you know, seam sealers should be applied over properly prepared and primed surfaces and not over direct bare metal. And it's important because this is where technicians, I was in a shop a few months ago, And the technician said, I know this bulletin inside and out, and I don't use products bare metal when I'm working on Toyota. I always put down this rattle can primer first because it's fast and easy. And my next question is, have you read 3 bullets earlier in that position statement where it tells you you have to be using a direct to metal or epoxy primer? They don't mention a one component aerosol primer in here. That's not acceptable. And there was the disconnect, right? And they're like, oh, I didn't even realize that. Again, if we're following, in all the OEM processes and procedures, we need to make sure that we fully, understand them throughout the repair. And then they do go in and talk about glass bonded flanges. And I point this one out because Toyota has identified that all glass bonded flanges need to be epoxy primed. They cannot be left bare metal, and you cannot use even if a manufacturer has a direct to metal pinch weld urethane primer, Toyota said, nope, you can't use it. You have to be putting it over a 2K epoxy primer. Even if the product you're using to glue the window back in says that it's a direct to metal product. So again, the OEM here is superseding the product maker's recommendations, and the product maker should have their products that work in alignment with this type of procedure. If you're not familiar with it and you haven't seen it yet, Honda did just release a new bulletin. This is for all Honda vehicles. And what they're saying is you must apply a 2K epoxy primer to all bare metal surfaces prior to applying seam sealers, body fillers, or other refinish products. And I highlight other refinish products here because this also includes undercoating, chip guard coating, products like that we need to make sure that we're following their best practices. And they go on in this bulletin right underneath this to say acceptable methods for applying a 2K epoxy primer. Because that's the next question that comes up quite often is like, hey, I hear you, but I don't want to tie up a boot cycle. I'm not driving the car up to the paint shop and tying up a boot cycle for 30 minutes because I can only get 5 cars through my booth in a day as it is. And if I have to take away one of those boot cycles, that's one more job that's not getting done. I can't be spraying out in the shop. That's why we use aerosols, right? Or we need direct to metal products. Honda goes on here to say that you can use a windshield cotton dauber to apply that primer. And per our conversations with PPG and with Axalta and these other companies, they're also releasing statements saying, yes, a windshield cotton dauber in 2 coats is the acceptable method for applying primers when you're not in a properly ventilated space. Still mixing it to the proper ratios, stirring it up thoroughly, and then applying it and allowing it to properly cure is a best practice for them and obviously for the OEM. So understanding those types of things and making sure that, again, we're following all the right processes and procedures. Coming back to FCA, so they also have a refinish repair guidelines. So this is like the bottom half here. I'm going to highlight the pre-refinish guidelines for repair, and they go on to say that all bare metal should be epoxy primed prior to applying seam sealer. All hem flanges and closure panels should be seam sealed, whether seam sealer is apparent or not. This includes those disturbed during the repair and those on new replacement panels. And it's key to point that out because FCA is not the only one to say this. All you guys are familiar with the fact that, when the panels come to the shop, they don't have seam sealer applied to them. You have to seam seal it because it's part of the corrosion prevention process. Right, that panel did not go through the same exact e-coat process at the factory that the entire vehicle did. And that's why some cases they come and they even have a completely different, they come in a black primer where the car came in like a light, drab olive or tan color. It went through a different process, and the OEMs have identified that you must seam seal them even if it's not apparent on that vehicle. In fact, FCA goes on one step further and says either duplicate the existing bead in shape and size, or where one is not apparent, seam seal the hem flange in discrete fashion. And we get asked, what 3M products, how do I do this? If you're not tied in or connected to us on any of our social media platforms or over at 3M Collision Repair Academy, we do have videos available that walk you through the process of how to replicate these OEM looks and appearances that are available to you today. You can check them out on our YouTube channel. We do a lot of stuff on Instagram and Facebook as well. But then 3M Collision Repair Academy We've got a lot of great content, not just around seam sealers and cavity waxes that we're going to talk about here later this afternoon, but the full repair process, right? Feather, prime, and block, and masking, and other operations that we go through on a daily basis. So I encourage you to check those out as resources and tools to be using. Again, sticking with some of the the OEM stuff. When panels don't come seam sealed, and I'm highlighting Nissan here, but there's other OEMs that have statements out there like this that say, these are the areas that you must be applying seam sealer. And if we're not following these processes and somebody's coming out to do a reinspection on a vehicle and they have a position statement or a bulletin like this, and they open up the door and they say, well, it says it's supposed to have seam sealer on here. Doesn't look like there's any seam sealer. My job is done. Right? I've determined that there's something wrong with the vehicle, and now we can send it to a shop to have it disassembled and find everything else that might be wrong with it. We need to make sure that we understand these bulletins and procedures to protect ourselves from that type of situation. And I do want to highlight here on the inner portion of this door where they have highlighted as far as an area to be seam sealed. Many makers where the shells are welded together there, you need to be seam sealing that seam, and it's going to become more critically important. In 2021, the Toyota Camrys are coming out with pressure sensitive airbag sensors in the doors. And if that seam is not sealed, and even if you have your vapor barrier on there and everything else is in place, the air is not going to travel through that door panel properly. And so it's going to offset the sensor timing. It's not going to trip it at the right speed. And that could lead to an injury to the occupants. Now, if you're sitting there thinking and wanting to ask the question, well, what if the windows rolled down? How would that be any different? There's sensors built into the regulator to tell the computer, hey, my windows rolled down at 50%. The computer says, okay, great. It sends a signal out to all the other sensors that this is the new pressure at which you should be seeing. And if you get above this pressure point, we need to deploy the airbags. If the window's up and that seam sealer is not there, it's not going to perform properly. So it's important to point that out in this type of situation because many manufacturers have these statements and positions available. So getting into undercoating and understanding, again, as one of those three legs, the importance of it as part of the repair process and what the OEMs are saying. Many of these vehicles may not come with undercoating in these locations from the factory because, again, the coatings that they put on from the factory are able to withstand much harsher conditions than some of the stuff we're using in the aftermarket. They go through extremely high temperature baths that are baked at over 400 degrees for 30 minutes or more. And they've identified that in some cases it's to help absorb, vibration and stone chipping, where from the factory they might have other coatings that do this. We need to make sure in the aftermarket that we're applying these. Toyota here again, they're highlighting and telling us these areas of the vehicle that need to have undercoating put on there in the event that we're doing any repairs, right? And you can see here by the rear around that floor pan, that front edge of that floor pan, right? That's a critical component that gets a lot of road wash and salt and rocks hitting it. You'll see that only one floor extension is actually coated and not the other. And that's simply because there's an exhaust that comes out on that other side, right? So there's an exhaust there that they don't need to be putting any coatings on there. They need to just have the heat shields up underneath there. And so they don't want undercoatings in those locations. It's important to point that out. We only want to be putting undercoatings where they tell us to put them. We got to make sure that we're not putting undercoatings in areas that they're not intended to be put or that the OEM doesn't recommend, especially when you get in around like wiring harnesses, brake lines, exhaust, and stuff like that. We got to be really protecting those. And from a 3M standpoint, we offer, if you're not familiar with our HGP system, the performance of this applicator is amazing. We do have the pouch kits available in chip guard and undercoatings, but we do have the option for large volume, high viscosity coatings to be sprayed through these panels in use of so you can have 28 ounces of rocker guard coating available to you in a gun that performs with all the functions and features of a, similar to a paint gun. It's just got an added feature of a pressure cup on top to be able to get those products to spray out properly. And part of the beauty of this system is that you could spray polyester spray primers, you could spray, undercoatings or gravel coatings and never have to really go over. You shouldn't ever have to be going over 20 psi on your gun, on your air inlet setting, right? It's on your regulator, because of the way this gun is designed and built to apply these thicker coatings. It really is amazing. So I encourage you, if you're not familiar with it, check it out. Check with your distributor or your local sales reps. So part of the corrosion protection process, cavity wax, a critical component of this, and understanding, the OEMs and again what they're saying, right? We're so far beyond the page where we read, what type of adhesive are we using. We're 3, 4, 5 pages into the repair, and I bring up this Toyota procedure because again, coming from a Lexus facility, these hinges from the factory are seam sealed on after it's been e-coated. So after it's been dipped, that e-coat is allowed to wick in and around and seal these hinges to prevent any moisture from getting in and starting corrosion, and they're seam sealed. But in the aftermarket, they're telling us that they don't want us to seam seal them, right? So you're going to paint the post, you're going to paint the hinge, you're going to bolt it back on, you're going to get your door to fit, and then you're going to apply cavity wax in and around those hinges. And how we're going to do this is using like an acid brush. And with our Cavity Wax Plus, I would take the straw, spray it into the cap, and then use a brush to dab it around the hinge and allow that wicking action to take place. It'll wick in and protect those metal surfaces. But they're also saying here, like in this diagram, you notice the front edge of the hood. We commonly see this as a missed area. They often point out the deck lid and other areas of the vehicle where cavity wax needs to be applied. And it's important to point that out. Unlike Nissan, who doesn't have seam sealer from the factory, when if you've taken a hood off and you've got to give it sort of that bump, that's the e-coat holding it to that hinge. It's what's wicked in, and it's created a tight bond between those two surfaces to prevent moisture. They're saying that when you replace these panels, they want you to use a seam sealer and not a cavity wax in those locations, right? So we'd be, in this case here, if we're bolting on a door and new hinges and they're telling us, hey, you got to put a seam sealer on the surface of that door hinge, using a one component seam sealer so that you have time to get it on, get it fitted up and adjusted, and wipe off any remaining material that might ooze out around that hinge is important. And again, these are simple things where if rust starts around that hinge and somebody comes out to do an inspection and says, hey, this car's been worked on, here's the repair procedure, it wasn't followed, what shop did this repair, now we've got ourselves in trouble. And this is what we're trying to prevent, because again, in this era, in this age, this is becoming important. And seam sealers and cavity wax are the first thing that anybody can spot in a repair, right? The next thing, in my opinion, is stickers left on parts and pieces of the vehicle that we're not removing. And that's another dead giveaway. If anybody's taken a car apart, pulled the front bumper off, and there's a washer bottle with all the OEM stickers on there, it's like, well, this car's been worked on. As a technician, for me, the next thing I was doing was, how far did they go? I'm going to dive into this even deeper. A, because I want to pick apart somebody else's work, and B, I need to know how far their repair went, and does it affect the damage that I'm about to repair potentially, and I need to know that information and document it. And we're going to talk about documentation here in just a second. But going back to Nissan, I want to talk about when we're referencing cavity wax, areas that can't be coated, accessed with a paint gun. We don't want to be blindly spraying primers and coatings into cavities, like in rocker panels, in sail panels. These coatings may not cure properly. They may take longer than needed. And if they pool up in those, pinch weld areas, they could become very brittle and actually shrink and open. Or if you come in with a cavity wax right after that, it might not allow them to dry properly, and it actually will plug the areas that are meant to be used to drain away water or prevent cavity wax from wicking in around our repair areas. So Nissan does a great job here highlighting that, in inaccessible areas, straight up cavity wax on bare metal, right? That's the best practice. And through our testing and our products, we've determined that is the best practice, very much so. And again, Honda here, like I want to point out, like they've even got the fuel door hinge. So if you're putting a new fuel door on a Honda and you're not putting cavity wax on the hinge, and the fuel door starts to rust off, what kind of problems could that lead to? The hood, the deck lid, these are common areas that get missed. Subaru even has these diagrams available where they tell you when and where and how much to be putting in. And they're showing that, it needs to stick to the sidewalls. And what's important to point out here is if it has to stick to those sidewalls and you have to have a certain amount of mill build, commonly I'll hear technicians say, I use, brand XYZ because I know I've got enough cavity wax in when it's running out all over the floor. Then I know I've got enough inside. But then my question always is, if it's on the floor, what was left inside the vehicle? If 75% of what I put into the vehicle is now laying on the floor and there's only 25% left, is there enough mill build on those surfaces to protect it? And say like the top of a rocker panel, is there enough on my weld up here to protect it from any moisture that might get into that cavity and start rusting the backside of that panel? With our cavity wax, we actually have a foaming action designed and built into it. So when you use a straw or a wand for it, it foams up upon application, but then that foaminess subsides. And when it subsides, that it accelerates the wicking action even faster. And that foaming action does go away, but it allows that to stick to the sidewalls. It doesn't drain and run out, right? There's a minimal amount that does flow as that foaming goes down and gets into like the lower cavities in these areas and runs to these low spots to protect it. But more importantly, it sticks where we want it. So especially like in sail panels and getting coverage up on top, it's very important to point that out. And how we've highlighted that is here we've built 2 frame rails and did a combination of squeeze type resistance and MIG welding. And the frame rail on the left, as you can see, went through that 500-hour salt tank, and we had no coatings, no sealers, no cavity wax. And at the exact same time, the rail on the right went through the tank, and all that one had was just a radius off bead around the outer edge of the flange, and cavity wax on the inside. There's no weld through primer on there. That entire flange, you can possibly see that it's all ground down 80 grit grinder marks on there. And that's how the cavity wax protects these panels. It wicks in around these areas and around these welds. You can see there's no rust there whatsoever. So in the event of like FCA, who doesn't want any weld through primer being used, they do want the use of MIG welding, mag welding, and squeeze type resistance welding. And in many of those locations, no seam sealer. The cavity wax is how we're going to protect those panels, right? And some operations, FCA calls out for like a weld sealing. And it's important to point out that that's different than a weld bonding. It's not the same thing. So we got to make sure that we also understand and know that. But other areas that we could be using cavity wax, and I want to highlight like dead front center here, is the radiator supports. A lot of times we can't get in, with a squeeze type resistant spot welder and get on those lower frame rail areas. We're actually MIG welding and heating them up. And even if we could get in there with the squeeze type resistance welder, we've got bare metal on both sides so that we have good continuity when we pull the button. We need to protect that metal once again. So we're going to have to be putting cavity wax in and around these welds after it's been painted, right? And I want to point out that cavity wax is meant to go in after paint during the reassembly process. And it's important to point that out. And what we've also done with our SOPs to help protect our shops is we've added 2 steps to our SOPs where we're pre and post photoing our application of cavity wax, because we have had some instances where shops have been flagged on reinspection because they went out and they looked at the estimate. They may not know when or where or how they sectioned a frame rail. They just stuck a camera in a rail, took a picture and said, well, I can't see cavity wax. They may have only found an access hole back by the strut, and you may have put a front crush cap on a Toyota Camry or a Lexus RX 350 or whatever you might be working on. If we can pre and post photo that application and tie it right to the document, and I prefer this type of borescope. I'm not endorsing this brand. It's actually this one right here. It links wirelessly to my mobile devices. So I can photo these repairs, I can upload them right to the estimate, and then it's documented and I know it's covered. And then if my repairs ever come into question, especially the usage of cavity wax, we can pull up that information and say, we have photos on this date. Here's before and here's after application of cavity wax. If you have any further questions, we'd like to know. Proper usage of cavity wax. We have some diagrams available to help us. Again, working with the OEMs, working with technicians, we've identified, proper usage and amounts in some of these areas. Our wand kits being designed to be trimmable, resizable, and always remain straight. They're stored in the original packaging. The packaging is designed for them to be stored. But I want to highlight the bottom here, like the areas and amounts of usage. What we've found in our studies, and we've done this, we go out to shops and we do this with technicians on a regular basis. So we just do these field studies. And on the low end of the scale, we've found that technicians should be using 1 can a week. And in many cases, technicians are using more than a can a week, depending on the size and of the jobs that they're working on. But realistically, if you have a shop of 5 technicians and you're not going through 5 cans of cavity wax a week, either one of two things are happening. Either you're not doing any work or fixing any cars, or you're not using enough cavity wax. And it's important to point out that cavity wax isn't just for welding and grinding. It's for anywhere that we've done any sort of dent pulling, panel replacement, even new panels that are being replaced, and paintless dent repair. That's one of the areas that gets missed quite often. Glue pull dent repair is becoming a popular thing in the industry. So if you're doing glue pull dent repair, keep in mind that the E-coat on the backside might have some fracturing in that surface substrate because it was dented, it was stretched. Applying cavity wax into those areas is very important, and highlighting that in a diagram such as this. And I know we didn't talk about MIG welding or squeeze type resistance welding or bonding or anything, but the lower portion of this, and more importantly, I want to draw your attention to the diagram here. This is, think of this as your section, rocker panel. We've got all 3 legs of what we discussed at the beginning in here. We've got our internal coatings, we've got our cavity wax, we've got our external coatings that could be like gravel guard, our base coat, clear coat, operations. We've got our seam sealer and our 2K primer underneath, and it's important because when you consider the new vehicles of today and how they're constructed, and this image here is all these different colors represent a different metal structural component of the vehicle, right? A high strength steel, a boron, a mild strength steel, and aluminum. The OEMs put these cars together and they're all intended to perform in a certain manner. If we allow corrosion into these areas to break down these panels and start corroding them, we're breaking down the molecular structure of those panels and in turn weakening the structure, which could lead to catastrophic problems if it's ever involved in another accident. So again, going back to the beginning of saying, like, these 3 elements are critical to preventing corrosion, and in many cases, in the event of a reinspection, very easy to spot, right? Replication of OEM look and appearance, and making sure that a cavity wax has been applied. It's extremely important that we're doing these types of repairs and so forth. So I can see a ton of questions popping up over here on my other screen. So if you have any questions at this point, in addition to the long list that I've been seeing kind of ticking away over here on the side, now's the time to ask them. I do have some time beyond the 4 o'clock hour, so I want to try to get to as many as we can here, and I'm going to turn it back over to Dave to kind of walk me through, and he's been keeping track of these for me.
Thanks, Ryan, and thanks for that great presentation. So what we're going to do is we're going to let the guy who handles our question here today, Dan Baumhart, he's going to go over and he's going to feed them over to you based on what's in the questions pane. Dan, over to you.
All right, Dave, can you hear me okay?
Loud and clear.
I can hear you.
Awesome. Great. So one of the questions here that I see is that Michael asks, how is cavity wax used on aluminum after painting?
The same way it's used on steel. What we found was, and I'm going to use Tesla as a reference. Originally, Tesla actually didn't want the use of cavity wax on their vehicles. And then a couple of years ago, they came out with the statement and said, hey man, on the steel components only, we want to make sure that we're using a cavity wax. And then working with Tesla more recently, they're actually going to be having, in all their new documentation coming out here shortly, is going to say on all aluminum replacement panels as well, we do also want a cavity wax because we're protecting aluminum from oxidizing, right? And it's important to point out that just because people look at aluminum and say, well, I love aluminum because it doesn't rust. And that's actually not an accurate statement, because if you look at steel and aluminum, they both oxidize. What we consider rust is the iron element in steel that turns red, and we consider that rust. In aluminum, there's no iron, so there's no red oxide material. It's just that white kind of powdery aluminum oxide is what it is on the surface, but that is actually corrosion. It's a very strong substrate, which is why they say sometimes aluminum is like a self-healing material, because it does protect it, but any top coatings that are applied to it won't stick to that aluminum substrate.
Okay, and then Kevin asks, on interior panels, how do you handle the commercial rust proofing products?
As far as removing them or replacing them?
Well, I think he means when you're trying to do a repair and you run into that, what approach do you use for that? I can't really, it'll be hard to see what the response is back from Kevin on a secondary question or confirmation.
I'm assuming that he's talking about, so if you have to remove any of the original coatings that might be applied in there for corrosion protection, it's definitely important to put those back in place. And in many cases, if they're using, say, like some of them have like that sprayed in coating inside the door panels, it's important, or even like roof panels. If you're doing any work on a roof panel and they've got like that sprayed on coating in there, it's important that we're always restoring that coating, but then certainly putting in cavity wax, and even cavity wax applied over the original rust proofing material will help provide that protection for the area that you may have damaged or disturbed.
And on to that end too, Edwin asks, a lot of this information was focused on bare metal preparation. He's asking if that's a lot of this stuff is applicable to the multi-material components on today's vehicles.
Yeah, so this is going to be pertaining to your borons, your high strength steels, your ultra high strength steels, like that Honda bulletin where we mentioned, like they only want the use of primer. Ford and Toyota have a similar statement out there, but they also have within that statement a disclaimer saying that unless you're using, and they actually call out for like body filler, 3M Platinum Plus and Platinum Select, because there's corrosion inhibitors in that product. If you follow the procedure for application in that time window of less than 30 minutes, they're saying you can apply body filler to those bare aluminum surfaces and still follow the right procedure for top coating it with an epoxy primer shortly afterwards, while you're still within what they consider an acceptable window. So make sure you're always following the product, that the OEMs are recommending, and then that you understand the proper application for the products that you're actually using.
Martin has a question about preparation or good protection for areas where you've welded. Is that something you can address here, at least?
Yep. So going back to what I had mentioned about cavity wax and Nissan's position statement. So when you look at like your, I'm just going to reference like a sail panel where we've got, like the original panel and the quarter panel coming together. It is actually a best practice, and many OEMs are calling out for this, and GM's got, in their new mid-engine Corvette, they've got a lot of stuff that we've been working with them on for repair procedures, where on the backside prior to, I should say, installing that panel, we want to make sure we're stripping back the original E-coat a ½ inch to an inch beyond the weld zone, so that we don't have any of that burnt E-coat or paint or soot on the backside of it. But even if we did, putting cavity wax on that bare metal surface will provide enough corrosion resistance for that. I didn't have it in one of my slides, but our cavity wax, when applied properly with 3 coats, surpasses 1,500 hours in that cell tank with any problems, and goes actually well beyond that time frame. And that is why the OEMs are saying, only use a cavity wax in those weld locations that you can't access with any other coatings materials. Just make sure you get in there with the cavity wax and get it properly coated.
Then a question from Dodge. He asks if the OEM painting process now is more akin to powder coating than actual painting.
To the best of my knowledge, it's not at this point akin to any type of powder coating. It is still a 2-component product that comes through. So the 2 components are coming through 2 lines that are actually mixed in the atomizing head as it's being sprayed. But yeah, as far as I know right now, there is no powder coating operation done at the factory levels. But I could be mistaken, but we haven't been, in our conversations with the OEMs, they haven't brought it to our attention that they've changed any of those processes.
Joshua has a question about frame corrosion protection and what's the best process for that. He says, for example, GM has a rubbery dipped style coating, and then Fords have a hard E-type coating. And he knows that Toyota, they've had some problems with some frame rust. And is there a recommended best practice for protecting frames?
So ideally, if a frame already has rust on it, bearing it with a coating isn't going to necessarily stop it. And then I'm going to throw this out there now because I know if somebody hasn't asked it, they're going to the minute I say this. I can't speak to the performance or properties or characteristics of anything like a POR 15 type material where they make claims that you can do that. I'm only speaking to 3M products and saying that encapsulating rust when it comes to coatings that are designed to dry is not a best practice because that rust still does exist. Especially if you trapped any moisture in there or you used a product and didn't get the right amount of application on there, moisture might get in and continue doing damage. So if there's rust, we got to make sure that we're removing all that rust first and then putting on the proper coatings on top of that clean, dry, bare metal afterwards. As far as some of the coatings that come on there from the factory, absolutely, if they're ever damaged, they do need to be reapplied. They do suggest products and processes in that case. So you mentioned 3M's got that, like the gooey, waxy material. They have recommendations for products to be used. Toyota in some of their vehicles has that coating on there. And for Ford rather has those coatings on there, and they actually call out our products to be used for that as well. But yeah, again, always check with the OEM for their recommendations or processes. But if you're going to coat, say, a brand new frame on a Toyota truck, make sure that it's free of any rust prior to applying any top coats on top of it.
And then Alan asks or makes a statement about how he manages truck bodies. He needle scales them after winter and then sprays them with paint directly to prolong their life due to the salt that they're dealing with. And he asks, is that pointless? Does he need a 2K epoxy primer first? What paint should I use that holds up against salt? So he's looking for some help there.
So that's a very good question. I would recommend absolutely, especially if you're needle scaling them down to bare metal, the use of a 2K epoxy primer. And in that case, making sure whatever product that you choose, you're following their best practices and their recommendations for application. And then certainly you can follow back up on top of that epoxy primer with something like a 3M undercoating. We have, paintable and non-paintable undercoatings that you could use on those frames to further help protect them against corrosion and chip resistance as well. So again, it comes down to what products you choose to use and just making sure you're following their recommendations for application. But I would say a 2K epoxy primer, in all of my laboratory testing, I found 2K epoxy primers to be some of the best performing products out there.
And then Mark asks if 3M has identified which two-component or epoxy primers from the major paint manufacturers are acceptable substrates for their single or dual component sealers. You follow that?
Yep. So we've tested all of them, and we haven't found any problems when being applied properly over a properly prepared 2K epoxy or even urethane primers. So we go through these testing procedures on a regular basis, and so we spray these panels and these things and put them through these performance tests. So there's not really, I'm not going to make a statement that there's, any one particular brand that stands out. But we do know that it performs very well with most all brands available on the marketplace, with the exception of some of your off-brand private label stuff. We haven't necessarily tested those. We just usually stick to like the major brand companies because that's what we see being used in body shops today.
And Greg asks if there is a recommendation for applying cavity wax in panels that are expected to drain, such as seams between inner and outer rockers.
Yeah, so this kind of goes along with another question that I commonly get that I'll touch on here too, is can I use too much cavity wax? And the honest answer to that is no, as long as we're making sure that those drain holes are free and clear of any cavity wax material. Our cavity wax does not dry. It does always remain in, as it over time it becomes more of like a jelly type material. But certainly when you're applying it, making sure that we go back and that the drain holes, say like in the bottom of the doors or the bottom of the rocker panels, making sure that those are still free and clear so that moisture isn't being trapped inside those panels on top of the cavity wax and swishing around inside the vehicle.
And then Greg also asks, some shops have been given or instructed to fabricate ropes with markers that indicate how much seam sealer to apply. Is the logic behind that available?
Yeah, so there's actually with our crimp, our estimating management software that we have available to the shops using 3M products, we can measure the lengths and the amount of materials being used and apply that directly to the estimate and provide the insurance company with a invoice for these operations, and especially effective when coupled with like the OEM position statements as far as panels that need to be seam sealed. So yeah, absolutely. You can get reimbursed for those products through our crimp system to compensate your some of your overhead costs in the repair process. And I guess for as far as the rope goes, you can use a tape measure, you can use a rope. There's several options available out there, but certainly saying like, hey man, I'm going to need like 14.5 feet at a 1/2 inch wide. I'm going to use 165 milliliters of 5887 to seam seal this hood. I go into crimp, I type that information in, I create an invoice and I submit it with the RO, and now I can get compensated for the material that's been used and then hopefully the labor as well if the estimators can negotiate that. Did I lose you, Dan?
Nope, I hit the button the wrong way. So James asked, after bumping a panel, is it okay to use an aerosol etch lock followed by the wax after it's dried on the inside of the panel?
Run that first part by me again. If I can use an aerosol etch?
Sure. He says aerosol etch lock followed by the wax after it's dried. So I don't see that he's popped back in.
Okay. I guess I'm not familiar with the aerosol etch lock. But I would say before the buffing process, typically before the vehicle is buffed, depends on which process in the shop. If you're buffing panels before you reassemble the car, making sure that all that compound is out of there before you put in a cavity wax is necessary, because we don't want to trap compound underneath cavity wax. If you're buffing after the car should be assembled, you really shouldn't have a problem cleaning out those edges, because the cavity wax is meant to be internally, not externally. I hope I answered that question. I guess I'm not familiar with the etch lock product that he's referring to.
Yeah, he hasn't popped back in the question pane, so we'll move past that one. Okay. And then Mark asks, is he to understand that 3M is now also approving the use of cotton dauber or acid brush as the application method for the underlying epoxy primer prior to seam sealer application? Do you follow that one?
Yes. Yep, absolutely. So that is a best practice, and through our testing and working with some of the paint companies, helping Honda develop that position statement where they call all for the use of that. We just want to make sure that we're getting enough epoxy primer on out past the width of the bead that we're going to be applying. And again, making sure, following the paint company recommendations, that we have enough mill build on the surface for protection and that it's fully cured before we're putting our seam sealers on top of it. So yeah, that is a very good practice.
And then Scott asks, can cavity wax be used in a joint that has not been repaired, i.e. an original door seam that possibly has some corrosion already? or would the cavity wax prevent further corrosion is what I guess he's asking.
Yeah, so even in cavities that we know that corrosion exists, putting in a cavity wax is still going to be a best practice. And I want to point out what it's not going to do is it's not going to seal up and stop corrosion. There is still the potential that corrosion could spread, but what we do know is that it's going to greatly slow it down and prevent any new moisture coming in and creating further corrosion. So it absolutely would be a benefit to use a cavity wax, even knowing that we might have some corrosion that started in these panels. Now, if you've got a rocker panel where half of it's missing underneath, at that point there, I would say don't waste your money on cavity wax. You're going to need a new rocker panel.
Okay, and then there's a question from Joshua, is 3M panel bond a recommended overwelding on box side wheel arches that and has there been any issues of separation due to corrosion?
I guess I don't understand the overwelding, but 3M panel bond is recommended by many of the OEMs, even in box side replacements, to be squeeze type resistant welded with. And if there's corrosion that happens to get in there, commonly what we see, so I'm going to refer to a Chevy box side because there's two procedures available. There's one that's a bond on only, and there's one that's a weld on only operation. In both operations, one of them it's step 10 and the other one it's step 11 is the implementation of cavity wax. And that's, again, it's at the bottom where it tends to get missed. And I've actually had reps call me from the field in shop saying, hey, it looks like there's rust all underneath our panel bond. It must have clearly failed and caused a problem. And then again, I walk through the repair procedure the same way that a re-inspector would. And I say, okay, step 11, can you tell me what you see? Take a photo of the inside. Can you run your finger on there? Do you feel any cavity wax? Well, if cavity wax wasn't applied and corrosion was allowed to start outside of the panel bond, it can certainly work its way underneath. And especially in the wheel arches where there's that foam, that seems to accelerate rust because they say it's a closed cell foam, but in my opinion, it's not a closed cell foam. Putting a cavity wax in there, absolutely, each and every time we have to do a repair on that box side. But that would be my stressor with that is we haven't found panel bond to be the cause of the problem. It's usually the rust has started somewhere else and worked its way underneath and loosened that bond and created a separation, whether it be vibration from driving or a subsequent accident.
And then Alan asks, is there a paint that you would recommend from 3M to be sprayed on top of the 2K epoxy primer, the trucks that they see a lot of salt during the winter?
So 3M doesn't produce paint. So I can't say that there's a 3M paint that I recommend. But we do have several undercoating options available that you could spray on top of that epoxy primer. And depending on the volume and delivery method in which you're searching out, we do have it available in aerosols and body chutes, and then absolutely in the HGP applicator that I had showed during this presentation. So I would say reach out to your distributor, or if you don't know who your 3M rep is, I'd say reach out to your 3M rep or your distributor and ask them which 3M products undercoatings they have available that could be sprayed over to the top of that 2K epoxy primer.
And then Dustin, that's where it was. Cavity wax before expanding foam is the question that he asked.
That's a great question. It's one that we've been getting a lot lately. So through our laboratory testing, we're actually working on the documentation for this, but I can tell you that the best practice is to put a foam in first and then cavity wax. The foam is corrosion resistant. And so even in the areas where we may have a weld, after the welding operation and after all the other, before it goes to paint, we want to, put that foam in there, absolutely. And then after paint, come back in and put a cavity wax in there and make sure that we're, find access points to come in from both sides to protect that panel even further.
Then I got a follow-up. So after bumping a panel using a door pick, can I undercoat the backside of the panel with an aerosol etch prime, then cavity wax after the etch prime is dried, with the goal of covering up the bare metal gouge marks?
So the best practice there, I would say, because I know that etch primer Again, like I mentioned at the beginning, it's because it's an aerosol 1K. Even though that it says etching, it's kind of some misleading information. The best practice would be to just put a cavity wax over those bumping spots where you've done your paintless dent repair work, where that rod has scratched that surface, because we know that performance alone will protect that metal surface. The use of an aerosol may or may, I can't say if it'll perform properly, because we don't recommend that being used. We recommend just straight up cavity wax being used on the backside of that panel.
Then Ron popped in with a question about cavity wax causing the melting of foam. Now this may have come before you made a response on that last one about cavity wax over foam, but just can you answer that one?
Yeah, so the cavity wax, as long as the foam is fully cured, the cavity wax, the solvents in the cavity wax shouldn't be melting the foams. So I would say just make sure that the foam has reached its full cure window and time allowed. And just as a reference, all of our products have those work and handling and sanding and cure times labeled on the side, and those are all referenced at 70 degrees Fahrenheit. So if it's colder in your shop, for every 20 degrees of fluctuation, you either increase or decrease those times that are listed on the product by half. So if it's got a 15-minute work window and it's 90 degrees, you now actually only have a 7.5-minute work window. And the same applies the other way. If it's only 50 degrees, you now have a 30-minute working window, which also extends your paint window and your sanding window as well. So just keep that in mind. So just allow the foam to get to its full, the end of its full cure window, and then come in and apply. And that's what usually I say, apply the foam prior to going to paint, and then after it comes out of paint, then go ahead and apply the foam on the inside.
Then speaking of temperature, you pop some temperature in there. Santos is from Florida, and he asks about the melting of cavity wax in warm weather or hot weather conditions. Is that typical? Is there a solution for that?
So we haven't seen any melting with our product, and again, our product never dries. It may soften, and we would have to get to some pretty high temperatures. And I know even if you parked a black car in the sun on a hot Florida sun day, your metal temperature might get up around 160, 170. But we haven't seen any like melting and ooze out of the material with our 3M cavity wax. But if it's something that you think you're seeing, I would definitely like to get in contact and understand more about it, or see what the application or the method is in which you might be seeing that performance from it.
Okay, and I'm going to pass this over to Dave Kappert.
All right, thank you, Dan. Great job of managing those questions. And there is one question that I saw multiple people ask Ryan, and they want to know if they can get their hands on a copy of the PowerPoint slide deck in some way, a PDF or whatever. Is that possible?
Yeah, I would ask, is there a way you guys can collect their information and do it in one, so I don't have happen to me what happened on Monday and have a bombarded inbox? Or maybe what I can do is I will share it with you guys to distribute out if possible. One way or the other, we'll get in touch and I'll get you guys a copy of what we presented here today.
Okay. So the answer to everybody in the audience that asked that question, it is yes, it's just details on how we're going to execute that.
Yeah, it gets to be a little overwhelming. I saw we had like almost 550 people on this call. And as we were talking before the program with Dave and Dan, our inboxes are full to the hilt already. So we just need to find a good way to get that out without overloading us with hours of detailed busy work. So yeah, absolutely. Yeah. We'll try to get you some information on this presentation.
And the other thing is we don't want to get overlap where we're going in both directions at the same time, sending a PDF to the person twice, so we can run in that. So yeah, I think the workflow streamlining is definitely a good idea here.
Yeah, we'll work on our side. It may take a couple of weeks to get that information out to you, but I've already actually have a note for it here on my wall from our Monday presentation to take care of that. And I was actually waiting to get that question today. So.
All right, very good. Appreciate it. Appreciate your time, Ryan. And
absolutely.
You know, we've had an audience that's hung in there right to the end here. Obviously, with hungry for knowledge and the way things are right now. So thank you for answering all those and taking the time. Thanks to the audience for your time and showing up and hopefully learning something here today, which was a very good session, we thought. And on behalf of Ryan Marrinan, Dan Baumhart, and me, Dave Kappert, and the ASE Education Foundation, you guys have a good weekend. We're going to close this session down. Thanks, everyone.
Awesome. Thanks, guys. Have a great weekend.